Hello everyone and welcome to this tutorial on data mining. Data mining is the process of discovering patterns and trends in large data sets by using techniques such as machine learning, statistical analysis, and visualization. It is a crucial tool for data analytics as it allows analysts to extract valuable insights from large data sets and complex data sets. There are several reasons why companies might want to mine data from a commercial perspective. Lots of data is being collected and warehoused. With the growth of the internet, e-commerce, and other digital technologies, a huge amount of data is being collected and stored in databases. This data can be mined to uncover patterns and insights that can help businesses make better decisions. Competitive pressure is strong. With the rise of globalization and increased competition in many industries, businesses need to find ways to differentiate themselves from their competitors. By mining data, companies can gain a better understanding of their customers' needs and preferences and provide better customized services to give them an edge in the marketplace. Computers have become cheaper and more powerful. Advances in technology have made it easier and cost-effective to store and analyze large amounts of data. This means that even small businesses can now take advantage of data mining tools and techniques to gain insights into their operations and improve their bottom line. Improved customer relationship management. One of the most important applications of data mining in businesses is in the area of customer relationship management. By analyzing customer data, businesses can identify patterns and trends in customer behavior, preferences, and buying habits. This information can be used to develop more effective marketing strategies, improve customer satisfaction, and ultimately drive revenue growth. In a scientific perspective, there are many reasons as to why scientists might want to mine data. Enormous amounts of data are being collected and stored. Scientific research generates vast amounts of data, including remote sensor data, telescope data, gene expression data, and simulation data. These datasets can be massive, making traditional analysis techniques infeasible. Data mining provides a way efficiently and effectively analyze these large datasets. Data mining can aid in classification and segmentation of data. In scientific research, it is important to classify and segment data in order to understand patterns and relationships. Data mining techniques can help to automatically identify these patterns and relationships within the data, allowing scientists to make more informed decisions and generate more accurate hypotheses. Data mining can aid in hypothesis formulation. By analyzing large datasets, data mining can help scientists to identify patterns and trends. This can lead to the formation of new hypotheses and the discovery of new relationships between variables. Data mining tasks can be broadly categorized into two main types: prediction methods. These methods use some variable known as predictors or independent variables to predict the values of another variable known as target or independent variable. The goal is to develop a predictive model that can be used to make accurate predictions on new and seen data. Examples of prediction methods include regression analysis, decision trees, and neural networks. Description methods. These methods aim to find patterns or relationships in the data that are not necessarily predictive but can be used to provide insights into the underlying structure or characteristics of the data. The pattern discovered through description methods are often human interpretable and can be used to generate hypotheses or explain behavior of the data. Examples of description methods include clustering, association rule mining, and anomaly detection. There are 6 main data mining tasks. First is classification, which is simply a predictive task where data is classified into predefined categories. 2. Clustering, descriptive task where similar data points are grouped together. There is association rule discovery, descriptive task where relationship between different items or variables are identified. 4. Sequential pattern discovery, which is a descriptive task where patterns or relationships between events that occur over time are identified. There's regression task, which is a predictive task where a continuous target variable is predicted based on input features. There is deviation detection, which is a predictive task where unusual or anomalous data points are identified. So, what is classification? Classification is a type of supervised learning, which means that the data used to build the model includes the class label for each record. The goal of classification is to build a model that can accurately predict the class label for new and seen records based on the values of their attributes. To build a classification model, a training set is used to learn the relationship between the class variable and other variables. The model is then tested on a separate test set to evaluate its accuracy. If the model performs well on the test set, it can be used to classify new and seen records. There are many learning algorithms that can be used for classification. They may include decision trees, logistic regression, decision tree-based methods, rule-based methods, memory-based reasoning, neural networks, naive, Bayes, and Bayesian, belief networks, support vector machines, and so on. And as you can see, there is an example of a decision tree classification task where a model is built using this training set using decision tree induction algorithm and which is used to learn the model. The model is created and we apply the model to a test set to check its accuracy, and if the accuracy is good, then it can be used to classify another set of unseen data. There are many applications of classification. The first one is direct marketing. The goal here is to reduce the cost of mailing by targeting a set of consumers who are likely to buy a new product. To do this, the company can use data from a similar product that was introduced previously. This data includes information about which customers decided to buy and which customers decided not to buy, which forms the class attribute. The company can then collect various demographic, lifestyle, and company interaction related information about all of these customers, such as their type of business, where they live, and how much they earn, which can be used as input attributes to learn a classifier model. Once the model has been trained and tested, it can be used to classify new and seen customers as being likely or unlikely to buy the new product. This allows the company to target its marketing efforts more effectively and reduce the cost of mailing by only sending materials to the customers who are likely to be interested in the new product. The second application of classification is fraud detection. The goal here is to detect or predict fraudulent cases in credit card transactions. To do this, the company can use credit card transactions and the information on its account holders as attributes. This might include information about when the customer buys, what they buy, and how often they pay on time, among other things. The company can then label past transactions as fraud or fair transactions, which forms the class attribute. Using this information, the company can learn a model for the class of transactions. Once the model has been trained and tested, it can be used to detect fraud by observing credit card transactions on an account. If the model predicts that a transaction is fraudulent, the company can take appropriate actions such as blocking the transaction or alerting the account holder. Classification can also be used to predict customer attrition or churn. The goal here is to predict whether a customer is likely to be lost to a competitor or not. To do this, the company can use a detailed record of transactions with each of its past and present customers to find attributes that might be related to customer loyalty. This might include information about how often the customer calls, where they call, what time of the day they call most, their financial status, and their marital status, among other things. The company can then label the customers as loyal or disloyal, which forms the class attribute. Using this information, the company can learn a model for loyalty. Once the model has been trained and tested, it can be used to predict whether a particular customer is likely to be lost to a competitor or not. This information can be used to inform retention efforts and help the company to keep its most valuable customers. In the context of data mining, clustering is a type of unsupervised learning, which means that the data used to build the model does not include class labels. Instead, the goal of clustering is to group the data points into clusters based on their similarities to one another. To do this, a similarity measure is used to quantify the similarity between pairs of data points. The most commonly used similarity measure is the Euclidean distance, which is appropriate when the attributes are continuous. However, other problem-specific measures may be used depending on the nature of data and the specific clustering task being performed. The goal of clustering is to find clusters such that the data points within a cluster are more similar to one another than they are to data points in other clusters. This allows analysts to identify patterns and trends in the data that might not be immediately apparent and to group similar data points together for further analysis. The first application of clustering we are going to look at is market segmentation. The goal here is to subdivide a market into distinct subsets of customers that can be targeted with a distinct marketing mix. To do this, the company can collect various attributes of customers based on their geographical and lifestyle-based information, such as their location, income, age, and their interests. The company can then use a clustering algorithm to find clusters of similar customers based on these attributes. Once the clusters have been identified, the company can measure the quality of the clustering by observing the buying patterns of customers in the same cluster versus those from different clusters. If customers within the same cluster tends to have similar buying patterns, it suggests that the clustering is effective and that the subset of customers within each cluster can be treated as distinct market segments, marketing efforts. The second application of clustering is document clustering. In this example, the goal is to find groups of documents that are similar to each other based on the important terms that appears in them. To do this, the team can identify frequently occurring terms in each document and form a similarity measure based on the frequencies of these terms. They can then use this similarity measure to cluster the documents into groups. The resulting clusters can be useful for information retrieval as they allow the system to relate a new document or search term to the clustered documents. This can make it easier for users to find relevant information and can improve the overall effectiveness of the information retrieval system. Overall, this example illustrates how clustering can be used to identify patterns and trends in documents, data, and to group similar documents together for further analysis and organization. The next data mining task we are going to look at is association rule discovery. Association rule discovery is a data mining technique that identifies patterns in data by predicting the occurrence of an item based on the occurrence of other items. The data consists of a set of records, each containing some number of items from a given collection. A rule discovery algorithm produces dependency rules that predict the occurrence of an item based on the occurrences of other items. The discovered rule can be used to identify patterns and trends in the data and make predictions about the occurrence of items in a collection. For example, a rule might predict that if milk is present in a record, there is a high probability that Coke will be present. Or it might predict that if diaper and milk are present in a record, then there is a high probability that beer will also be present. There are several applications of association rule discovery technique. The first one is marketing and sales promotion. Association rule discovery is a useful technique in marketing and sales to identify patterns in customer behavior. This technique can be used to identify rules that suggest association between different products. For example, the rule bagel, arrow, potato chips suggests that customers who purchase bagels are also likely to purchase potato chips. This information can be used by retailers to create targeted promotions or product placement to encourage the sales of these two items. Retailers can use the rule to identify opportunities for cross-selling other products as well, such as creating attractive products that might be in bundles or in some sort of special display for related items. Association rule discovery can help retailers to understand their customers' purchasing habits and create targeted marketing and sales strategies to boost their sales and profits. There are many challenges associated with data mining. One challenge is scalability, which refers to the ability of data mining algorithms and systems to handle large amount of data efficiently. As the amount of data available for analysis continues to grow, it becomes increasingly important for data mining algorithms and systems to be able to scale up and handle large dataset efficiently. Another challenge is dimensionality, which refers to the number of variables or features in a data. High dimensionality, or rather, high dimensional data can be difficult to analyze as the relationship between the variables may be complex and hard to understand. Also, another challenge is complex and heterogeneous data can be a challenge as data can often be very diverse and may come from a variety of sources with different formats and types. This can make it difficult to integrate and analyze the data effectively. Also, data quality is also another important consideration, as poor quality data can lead to inaccurate and misleading results. As ensuring that the data is accurate, complete, and relevant is very critical to the success of any data mining project. Data ownership and distribution can also be a challenge, as data is often distributed across multiple sources and may be subject to different ownership and access restrictions. Ensuring that data can be accessed and used legally and ethically can be a complex process. Another challenge is privacy preservation is also another important consideration, as data mining can often involve the analysis of sensitive personal information, ensuring that the privacy of individuals is protected while still allowing for useful insights to be gained from the data can be a challenging balance to strike. Finally, streaming data is a challenge that is becoming increasingly important as, um, as the amount of data generated in real time continues to grow. Handling and analyzing data as it is being generated in real time can be a complex task and requires specialized algorithms and systems to be able to process the data efficiently.